Hello, welcome to this video where we shall be discussing the different types of numbers. If it's your first time, coming on this channel, please feel free to subscribe so that you don't miss out on the updates that will be uploaded in future. Okay, so when we talk about the types of numbers, there are two categories that we start with. Okay, so we're saying types of numbers, or we call it the number system. So we have what we call the non-real numbers, okay? And then the opposite of non-real is just the real numbers, okay? I'm just gonna use some sort of a flow chart so that we see and we make life easy. So non-real numbers, these are basically numbers that we hardly encounter within the school system, like we don't necessarily use them in detail, except for just identification purposes. So an example of non-real numbers could be, let's say, the square root of a -5, okay? Square root of a negative number does not exist. That's why if you punch this into a calculator, you'll get something like an error, okay? When you talk about, let's say, the square root of -4, so we can get the square root of 4, but we cannot get the square root of -4. So at higher levels of education, these numbers do exist. I mean, they have solutions, and their solutions will be called what we call the complex numbers, or we sometimes call them imaginary numbers. Okay, so that is under the non-real numbers. And then for the real numbers, whatever we've dealt with or whatever we're gonna work with within the school years for primary and the secondary falls under what we call the real numbers. Now, these real numbers are divided into two again. We have what we call, I'll just write them this side. We have what we call the rational, okay? And then we also have what we call the irrational numbers. So in other words, the real numbers can be divided into two, rational and irrational. So let's go down and break down what are rational numbers. So rational numbers are basically numbers that can be expressed as fractions, okay? Numbers that can be written in terms of fractions. Now, what happens with these fractions is that we have different types of fractions, okay? Number one, we have what we call the common fractions. That is your normal, proper, improper, as well as the mixed fractions, okay? That is A over C, where, of course, A and C are basically numbers. Two, we have what we call the terminating fractions. Okay, terminating fractions, these are decimals that always come to an end. An example, you talk of 1.2, talk of 0.6 or 0.9. For as long as there's an end to that fraction, then we call it terminating. And then number three, we have what we call the recurring fractions, okay, recurring numbers. All these form what we call the rational numbers. So for as long as we have n of these, then we can say the numbers are rational. An example of recurring could be maybe 1.2, and then the number continues. Or 1.5, 5, 5, 5, and then the 5 never ends. So that number that is repeating itself is what we call the recurring number. Then the entire thing becomes a recurring fraction. Now, besides this, we shall see as we move forward that all these three might apply to whatever falls under what we call the rational. Now, we have what we call the irrational numbers. Irrational numbers are basically numbers that cannot be expressed as fractions. In other words, just the opposite of the rational, okay? So in these numbers, they do exist, but not as fractions. An example, if you talk about the square root of imperfect numbers, an example, the square root of 5. Yes, when you punch this in the calculator, you're gonna get an answer, which is more like a decimal, but it never ends. It just continues and fills up the calculator. We have what we call pi. When you put pi in the calculator and try to press the equal signs, the number that you're gonna get is going to be just continuous and will not end. And then we also have, let's say, the cube root of numbers that not perfect cubes, maybe the cube root of 26. You punch this in a calculator, you're going to get a very long fraction. So that is irrational, okay? Then whatever comes under the rational can be, okay, so if it's not rational, it's going to be what we call the integers, okay? And we know that integers are positive and negative numbers, okay? An example, you can have the -2, -1, 0, 1, 2, 3, 4, 5, and so on and so forth. Then below the integers, I can talk about the whole numbers. Okay, so whole numbers, these are basically counting numbers, but you have to include the 0. Example will be 0, 1, 2, 3, 4, 5, and so on up until infinity, okay? Then below the whole numbers, we have what we call the natural numbers. Okay, so natural numbers are the typical counting numbers, which is 1, 2, 3, 4, 5, 6, 7, and so on and so forth. So the difference between the natural and the whole is that there's a 0 for the natural, and then there's no 0. Sorry, there's a 0 for the whole number, and there's no 0 for the natural numbers. The integers come from the whole numbers, but there has to be a negative part on the other side, okay? Then what we can conclude is that whatever is below the rational number automatically becomes rational, okay? In other words, all integers will be referred to as rational numbers. All whole numbers are going to be referred to as rational numbers, and then all the natural numbers will also be rational numbers. Now, sometimes there are symbols that are used for these particular numbers. An example, the natural numbers will normally be represented with n for natural numbers. And then the whole numbers will usually be n with a 0. Okay. Then integers, we sometimes use what we call the z. And then rational, we use the q. And then irrational will be a q with a prime somewhere there. And then the real numbers, we normally use that. And then for this non-real, it's something, I don't know how the real numbers will be, but somewhere there. So now, having discussed that, okay, because symbols are not really relevant or important, but for as long as we know how to categorize the numbers and how to represent them, that is what matters. Okay, so let's look at some applicable questions that could come under the different types of numbers, especially for the grade 10s, okay? So we have this table where they are telling us that all we need to do is to indicate the different types. Okay, sometimes they can ask you to use a tick or just use a cross just to indicate where it falls, okay? Now, remember what we said, a number can either be real or non-real. Okay, this is the first step. Then if a number is real, it can either be irrational or rational. And then if it is rational, that number is going to be an integer. Okay, automatically. Then if it's an integer, it's going to be a whole number, and then it's going to be a natural number. Remember, with all these numbers, we don't have decimals involved. The decimals will specifically focus on the rational aspect. Okay, let's see. We have 2. 2 is a real number, so I'll tick. Is 2 irrational? No, 2 is rational. But 2 can also be found amongst the natural numbers. 2 can be found amongst the whole numbers. 2 is also an integer. So all these ticks apply to the 2. Then when we look at the next one, which is the cube root of -216. So the first thing to do is for us to simplify this into just a single value. So we know that if we simplify that, we're going to get something like a -6. So it is the -6 that we are judging against this criteria. Is -6 a non-real number? No, it's a real number. Is -6 irrational? No, it is rational. So it's either rational or rational. Is negative 6 a natural number? No. We don't have negative numbers even with a whole, but negative 6 can be an integer or is an integer. All right, then we look at 12,3 with a dot, okay? So 12,3 with a dot, or some people would also write it as 12,3 with a bar on top. It simply means that this 3 repeats itself, so it's a recurring number. So recurring numbers are under the real numbers. Recurring numbers, since they can be expressed as fractions, we said they will be rational. Recurring numbers, we don't have them as natural, we don't have them as whole, we don't have them as integers because we don't deal with fractions under the other aspects. Then square root of 5, we know that 5 is not a perfect square. We cannot find this number that easily. So there are decimals that are involved. So of course, this is a real number. And then we are seeing that it's going to be irrational, okay? And if it's irrational, it cannot be rational. And automatically, when a number is rational, all the others will just automatically fall away. Then lastly, we have the square root of 12 minus 18. So we know that 12 minus 18 gives us negative 6. And then we're focusing on the square root of negative 6. So root negative 6 is a non-real number. And if something is non-real, then it cannot apply to all the other aspects. So that is how this question would have been answered. All right, then let's look at this. They're telling us to use the list of real numbers. Now they are focusing on just real numbers. In the block below to answer the questions that follow. Now they want us to write the whole numbers. So whole numbers, we said negative and positive numbers, but with a 0 included. So which means we have this. We have that. These are the only two. So it's 0 and a 5. All the others are fractions that are not part of our interest. Then we need what we call the irrational numbers. Okay, irrational numbers, we said, and numbers that are not perfect, whatever, perfect roots, or they have fractions, or they have decimals that don't end. The only answer I'm seeing is this negative root 3. That is the only irrational number, in as much as it's negative, okay? Then one negative rational. Okay, rational is one that can be expressed as a normal fraction, common fraction, decimal fraction, or something of the sort. So negative, we only have this. Since they wanted the negative, so it's going to be negative 1 over 2. So that is how we would have answered that question. Let's look at question 2. If a of x, now this is a function of a times of x, is equal to the square root of 4x plus 1 over x, find the value of x such that this function is undefined. Okay, now we know that for something to be undefined, okay, we're saying that the denominator must be equated to 0. So we're saying that the only denominator we have is just x. So which means we're going to say that x must be a 0. Then 2.2.2. Okay, our focus will be just the denominator. We don't care about what is inside the root sign. For as long as it is undefined, denominator must be a 0. Then for non-real, what we're saying is that for something to be non-real, there has to be a negative within this root sign. Okay, so what I'm going to do is I'll get the 4x plus 1 and just say it should be less than 0. They want the value of x such that it's undefined. So I'll move the one that side. So 4x will be less than negative 1, and then x must be less than negative a quarter. So all numbers that are less than negative a quarter will satisfy this question. Now, since they just say their value, you can take just one number that will be less than negative a quarter, but this will represent all the solutions for that case. Then 2.2.3. Okay, a number or a value of x that is gonna make the whole thing a rational number. So we say for something to be rational, we should be able to find the square, or we should be able to write it as a common fraction. An example, if we put a 0 here, this is going to be undefined because of the denominator being x as well. If we think of 2, I think 2 will be perfect, no? Because 4 times 2 will be 8, plus 1, that's 9. Square root of 9 will be 3, then over 2. So we can say x can be a 2 in that case. For 2.2.2, please, you can use this, or you can just choose any number that is smaller than this negative. So an example, you can say x is negative 2, or x is negative 1. Just saying any. Remember, they just want one value of x. Then lastly, question number 3. Question number 3. They're telling us that 1 minus root 5, 7, 2 over 3, 0, and then all of that. They want us to write down the irrational. Remember, we said irrational. Those are basically numbers that we cannot write as common fractions, okay? Let's see, what do we have? This is gonna be non-real. This is rational, rational. Then this, we have a root 5 somewhere. So this will answer 1 minus root 5 becomes irrational. Then for non-real, we said we must have a negative within the square root. I think that is where we have negative 16 over 4. Don't stress with simplifying it. Remember, it's more like a matching question where you just have the answers there, just get them and then fill them within the spots that we are given. All right, so that is how these numbers and their types do operate, okay? So thank you very much. Please feel free to come again.